what we'll do is that I'll just take you around. Yeah. Unfortunately, it came at a time when we have a site meeting, and we have the rest of my team there. And then I will take you around, show you what the project is about, and then if you have questions you want to ask, you can ask. A construction site is dangerous. Unfortunately, we didn't provide for you the helmet, and I hope no injuries are going to happen. But what is happening is this site, the way it was, it has a very hard rock down here, and excavating a rock is very expensive. So what we did was we went up to where the rock, we could excavate the maram, and then we raised the building to avoid cutting. And this below is where we have the basement, parking. On the podium level, we have got offices and shops and more parking. And then where we are here is the main parking. And you can see there's some trees that are already there, and we have to save them. Then on every floor, we have got different suites for offices. I don't know how easy it will be for you to see the concreting and so on and so forth. But I think we can take you down just to see how the site is going on. How many of you have been involved in construction sites? In your attachment, your PJs, your you have been? Oh, a good number of you have been. Okay. Have you been involved on a project of this scale? What are you doing? Huh?
An office.
An office. You have a basement?
Yes.
In the basement, the most critical thing, I'm sure you know this on your BT, is keeping water away. Waterproofing is the most important thing. And because you fail in the waterproofing, you're in trouble. I don't know whether you'll be able to see how we do the waterproofing here, but let's just go around and I'll show you. Basements are below ground. They need to be ventilated. And to avoid mechanical ventilation, which is expensive, we raise the building so that if you look at those black things, that is opening. And we have it all around to allow natural ventilation in the basement. So we just went halfway down the basement. Then if you look at the column structure, right now you may not see it very well, but it is designed such that you maximize on the parking. Maximum the parking. What I mean is that we have used a grid system that allows for 3 cars. Like here you can have 3 cars. It's 7.5 by 5 deep to allow the depth of a car of 5 meters and a driveway of 6 meters. Because in a parking, I find most of you students doing grids of 6 by 6. And then in a 6 by 6, you can only park 2 cars, and you leave space between the 2 cars that you don't need. And yet that parking is expensive. So you try to make sure you have maximum parking in the ground and sufficient driveway for the cars without any wastage. So here we have got about 53 or so cars. Remember, the other wall is the concrete wall. Ideally, we won't use this as office space, but it was cheaper to just raise the parking and go down. That's why we put the cars there. And just by coincidence, we were commissioned to do the next property here. And we were trying to save these trees from our side. But now that we will do that with the plots, we'll still save them, and then you will end up with a good number of trees, because if you find a tree on the site, whatever cost, try and save it, because it's the most difficult thing. It's very easy to cut it, but creating it will take years. So I'm trying to save it. That's why we actually trim to leave the building having sufficient amount of wood. Anyhow, this is the building, and the main entrance is actually to minimize in terms of the services. So we have got a fire escape, one staircase on that one, the main here, so that everything works together. But that's the main entry. There is some stuff down there, you can go up, and there's also an entry you can come in to the different floors. So then after that, go out that way, the outside. But there is nothing like a fire escape, meaning that the staircase is kept there until the day there will be fire so people can use it. A fire escape is nothing but an alternative route of exit. Although when you are dealing with it as a fire escape, there are certain things you do, like for example, you pressurize it to make sure in the event of fire, the smoke does not stay in the fire escape, and the fire goes out. You also have doors with a certain amount of fire resistance. You can see that's the main staircase. The staircase is here. And what you look at is what are the possible alternative exits should the fire occur on that side? What will be the next possible alternative? That's what you look at. That's why we located this one here. Because what happens is if fire happens on that side, people will run this side. Or if fire happens on this side, people will run to the other side. So it is not that people will run to the fire escape and go down. They will run to where because fire can happen toward the fire escape itself. Okay, so it's the alternative. This is a typical floor. This will be a one suite. It is once it's finished, it will be one suite. And then we, like I said, we have focused all the services here. And you can see what happens.
I'd like to understand the system that you're using to support your ramps. Yeah.
Support it?
The ramps.
Systems.
Yeah.
You mean the ramps for the cars?
Yeah.
Okay. The ramp on the ground, on the one we walked in, is right sitting on the ground. So just concrete and hardcore, and you drive through. The one on this other side is just a slab, which is spanning across, but it's also supported below because it's on the ground also. But a slab, a ramp is nothing more than an inclined slab. So there's no special system. Why do you ask that?
My concern is what happens to all that space below it. Basically, below. Yeah, as in like basically structurally, like how does it work really to have it supported? You have systems which are suspended.
Okay, like the one that we have down there is really sitting on the ground, and the one that's on this other side, yeah, is also like on the ground because it's a very small space. But normally, what we normally do in ramps, this one is really on the ground. But what you normally do is that triangular space that is left below it, we normally put water tank just to make use of the space. But a slab is this slab here, is inclined, and the same way you support this, the same way you support the ramp.
Yeah. You can see there's some columns that are varying. The dimensions of some of the columns are varying.
Yes.
Would there be any reason for that?
Yes. The ones here, there are two types of columns here. You see, in a building, the one that you saw outside, the one you saw earlier on, those ones are aesthetics. The one that you saw, which are big, circular, these are aesthetics, trying to give a certain impression of the building. But columns vary for different reasons. One, if, for example, this building was much taller, and you'd have a podium which is much lower, the core, which is taller, will have more weight. So you will tend to do larger columns for the buildings that are going, the parts that are going higher than the rest. Those columns on the outer edges.
In the detailing of the design, is it that you involve the structure? Because I can see that some places the beam patterns are diagonal, and then you have some beams which are larger than.
That's a good question. You find structural engineer, mechanical engineer, electrical engineer, all of them, and they're here today. What happens is that when you design as a team. And sometimes architects tend to dream too much. Just dream and dream and dream until you realize it's a dream. The engineer tells you, no, your dream, I doubt that I can achieve that. So you come and start the system. Now this design, the way we have designed it ourselves, we wanted this column. You see this circular column? But to do this kind of slab meant that we had to cantilever all the way to the end. The engineer said, no, it can't work, you can't support it. So we had to come up with a device of supporting this and giving an apparent feel of a free column. So we introduced a diagonal column, looking and feeling freestyle. Yeah. But the thing is that we work as a team, electrical, mechanical engineers, structural, and all those together. And any building that should be done has to be in line with the times. So, all the buildings, most of them now, are cabled to accept IT. Now, the optic fiber, you know, is a recent development in this country. Before, we have been using wireless or using normal cables. But this particular one, we have got optic fiber because they are available. And you bring it to what we call up to the backbone. The backbone is a set, what we do is that we will bring the optic fiber, then every unit here will be cabled up to the core. You see the one I told you, the core? We have got what you're calling the backbone. And everybody will be connecting. Will be connecting to the backbone of which is in the service core. And then you do your connectivity in accordance to your need. But in terms of the design, what you do is that you provide the core in terms of the services, telephones, security, and all of them within one core. Only supply. In the past, what you've been doing is just using normal cabling. But you'll do what we call structured cabling. Structured cabling is a cabling that will take voice data and it's voice and then power will then need to be integrated into it. But in terms of the form and the look of the building, no, there's not much. It's basically a service.
In the common area, are you intending to do like a false ceiling?
The common area.
Yeah, and what would the height be to allow for service?
Yeah, we are okay. This building is floor to floor height is 3 meters, 3.2. 3.2. When we finish this building, we'll leave it like this, but it will be painted, and the floors will be left with screen. And then the individual persons will then come and finish their units to their taste. Yeah, but the toilet, because of the services and the common areas, we are going to do false ceiling to make the building look nice.
And what is the height, considering you have beams and you need to allow for service?
I said you have got 3.2 floor.
Yeah.
3.2. You move the beam. In terms of water and recirculation, those two tanks, one of them we are harvesting the water from the because you have one tank on this side and the other side. Grey water management, that is tall order. Because although it's desirable from the green point of view, it's also quite expensive. So when you're looking on a project like this, which is for sale, when you look at the gain in terms of value, it becomes a bit uneconomical. That's the problem with the green technology. I think it works. You can only maximize it on institutions.